Hi, my name is Zachary Acosta, and today I'll be presenting a TE video for tau beta pi with the method of sections for statics. Alright, the first thing we're going to start off is doing an example problem. And if you do not know, kips are 1,000 pounds. Okay, and then, so this is a truss problem, and the goal in this problem is to find the force in GF, in the member GF, GD, and CD. Alright, when dealing with truss problems, we have two options, either the method of joints or the method of sections. When questions ask for all the members in a truss, then you would use the method of joints. But since we're only asked for particular members in the truss, we can use the method of sections and only find the particular members that we are looking for, which are GF, which is right here, GD, which is right here, and CD, which is right here. Alright, the first step now is to find global equilibrium, which we will do by looking at the two ends. Here on the right end at joint E, we have a roller, which means we will only have force in the y direction, or EY. And notice I drew it upward, opposing all the downward weight of the members. At the fixed point A, we will have vertical AY force and horizontal AX force, because it is a fixed joint. Now, here at the fixed joint, you look at the rest of the truss, and there are no other horizontal forces. So that means AX is equal to 0 and does not exist at the fixed point. Okay, next. We will take the moments. So the first step, we want to find global equilibrium by looking at the two joints like I said earlier. So now we're going to find AY and EY. First, you want to take the moment at one of them. So we'll take the moment at E. The moment at E is equal to 0, which is equal to, alright, so at the moment, when doing moment, what we want to do is look at the force, whether it's, you put your thumb right where the joint is, and if it's counterclockwise, it's positive, if it's clockwise, it's negative. So the 7 is counterclockwise. So we'll have 7 times, and then we need the distance away from the joint. The distance, we're going to make all the distances 2 feet. 2 feet, 2 feet, 2 feet, and then the distance up here, 2 feet. Okay, so 7, so moment is force times distance. So we have 7 going down times 2 plus the 4 times 2 plus, or times 4, I mean, my bad, plus 9 times 6. And what we have here will be plus, and then 8 AY. So all this is equal to 0. We're going to move the AY over, will be negative because if you look, it's clockwise to E. So we move the AY over. AY is equal to 14 plus 16 plus 54. So all that over 8, we'll get that AY is equal to 10.5. Okay, now next, what we'll do, oh no, my bad, this is 9.5. Okay, now next, what we'll do is, now that we already have AY, we can just do sum of forces in the Y, and we can find EY. So I'll do it right here. Fy is equal to 0 is equal to 9.5 minus 9 minus 4 minus 7, then plus EY. We're going to have that EY is equal to 10.5. And now we have AY and EY, and that completes step 1. Here, I'm going to write these up here. Now, the next step is that we want to cut through. We want to cut through the members and begin to find our free body diagram. When you're cutting the members, you want to have at most 3 unknowns because we're only going to have 3 equations: the sum of forces in the x direction, the sum of forces in the y direction, and the moment equation. So we can only have 3 unknowns for the 3 equations for us to be able to solve all our unknowns. So we have GFs, GD, and CD right here. I'm going to cut through. I want to choose the least complicated side, or the side with the most knowns. Here we have 7, and we know now that EY is 10.5. So we have all the forces on this side. So we're going to take this side of the free body diagram. This is joint D, this is joint E. We're going to have, alright, my bad, I messed this up. This is 10.5 and this is 9.5, my bad. So this will be 9.5 pushing up, and this will be 7 kips coming down. We have GF. Okay, for these forces, we do not know if they are in tension, pulling away, or compression. So I'm going to write them first in tension, and when I solve the equations, if they're negative, that means I was wrong and they're flipped in the other direction. So this would be in compression, which we'll see later. This is GD, and this is CD. Okay, now we're going to begin solving these. The first thing I want to do is take the moment at the point where I can take out the most forces. What I'm saying by that is if I take the moment about D, these forces can affect the moment, so I can only look at GF and E. And we already know E, so we're going to look for GF, which is our unknown. So the moment about D is equal to 0, which is equal to, we have the 9.5 going counterclockwise, which means if 9.5 times 2 plus GF and the distance 2 because EY is 2 away from the joint D, and GF is 2 upward from D. So we're doing the distance away. And now we find that, okay, these two are positive, so we know that GF is going to be negative. We move it over, and GF is equal to negative 9.5 kips. So now that we find that GF is negative, what we do is come back here, and what I like to do is change the direction here. Now we can make this positive. So now we have GF is equal to 9.5 kips. We have two more unknowns, GD and CD. So now that we have GF, the next thing I want to do is look and what's the next one where I can just solve for one unknown. If I look at the sum of forces in the Y, EY, I know 7 was stated in the problem, and GD is the only thing opposing those forces in the Y direction. So I'm going to solve for GD. F of Y. Sum of the forces in the Y is equal to 0, which is equal to, we know that this is 2 feet and this is 2 feet, so we can say that this angle is 45 degrees. I'll put that right here, 45 degrees, and we want GD, we want GD sine of 45 because we want the Y component of the GD force. And then minus 7 plus 9.5. So then this will give us that GD is equal to negative 3.54 kips. With this, we have a negative again, so that means GD was also in the wrong direction. It is actually in compression. And now we have our second member. 3.54. Okay, now the last step. We have done moment, and we have done sum of forces in the Y, so our last step, sum of forces in the X. And here we'll be solving for CD. Sum of forces in the X equal to 0, which is equal to, we have positive GF, which you know is 9.5. Then we have cosine of GD, and then subtracted by CD, which means CD is equal to 9.5 plus 3.54 cosine of 45. And this comes out to CD equaling 12 kips. So CD is positive, so we got that right, and CD is in tension, or CD is in tension. So then, okay. So this is the method of sections. We cut the truss in half, looked at the side with the most knowns, then we take our free body diagram, drew our forces, and to solve for them, if they were negative, we knew they would switch from a tension to being a compression, and if they were positive, they were a tension. So now we have GF, we solved our three numbers and found that GF is 9.5 kips and it's a compression. GD is 3.54 kips and it's a compression, and CD is 12 kips and is a tension. Thank you. This has been the method of sections.